just 1 and 2 as a warm-up. So now we have this kind of thought process to work through proofs from segments. That's always going to be kind of your reasoning, how you reason through a proof. Might be helpful to have either or both the list of properties that you picked up yesterday, that pink sheet, or your properties packet, if you need the packet out. All right. So let's look at proof number 1. I need your attention up here, please. In proof number 1, so look at what you're given, look at what you're trying to prove, label if you need to. We are given angle QPS. So remember from chapter 1, the way an angle is named, you follow those points, and the middle letter is the vertex. So angle QPS, it's this whole angle here. So I'm not going to mark it because it includes another angle in there, but QPS is congruent to TPR. So this angle is congruent to this angle. They overlap each other a little bit. We are trying to prove that angle QPR, so this small angle here, is congruent to angle TPS, so this small angle here. So I'm not going to mark that. I'm trying to prove that. So I don't know off the bat that they're congruent. That's what I'm trying to get to. So statement A should be what I'm given. So angle QPS is congruent to angle TPR. And that reason is given. And then remember, you're always starting with the given. You have no choice but to start with what you're given. And now what's a conclusion you can make? And then you work off of either what you're given or you work off of your diagram, your picture. So now if you look at statement B, we went from saying these angles were congruent to saying the measure of angle QPS is equal to the measure of angle TPR. So this is kind of the same thing as saying segments are congruent, so their measures are equal. It's just angles. Angles are congruent, so their measures are equal. What would that reason be, Katie? Yes. So there's a definition of congruent segments. This is definition of congruent angles. If the angles are congruent, the measures of the angles are equal, or vice versa. If the measures are equal, the angles are congruent. Okay, so I am going to make a mark. I recommended doing this yesterday. I can find the different color pen I was looking for, which I cannot. So I guess I'll mark it with, want to choose a color that looked different enough. So I'm just going to make a mark on statement A because I've now used statement A. I've used that to make statement B. Okay, now statement C. If I look through this, it's helpful for this one to look at your picture. So it says angle, the measure of angle QPS is equal to QPR plus RPS. Likewise, angle TPR is TPS plus RPS. Reason? Any thoughts, Quinn? Yes, so notice it's saying that first line is saying QPS, this whole angle is these two smaller angles added together. That's angle addition. And then the second line is this whole angle is these two added together. So like we had a segment addition postulate, this is angle addition postulate. And notice I haven't crossed out lines B or C. So now I'm using lines B and C to make further conclusions. So I'll model where to go from here. Let me highlight. So in line B, I said that measure of angle QPS, measure of angle TPR are equal. And then notice in line C, I stated QPS was equal to something, TPR was equal to something. So what I can do from here is make a substitution. I can put this whole thing in place here and this whole thing in place here. So I can say this, that the measure of angle QPR plus the measure of angle RPS is equal to this, the measure of angle TPS plus the measure of angle RPS. And the reason there is substitution. Okay, so again, I've highlighted these two things are equal. Here's those two things. So the statements that they're equal to, I can set equal to each other by substitution. Now, when you look at this equation that we just wrote in line D, so now I've used line B and I've used line C. So now I'm at line D and I have to go off of that. Anything you notice about this equation? Quinn? Yes, notice RPS is on both sides. Okay, normally when you have an equation where you have the same thing on both sides, you can subtract it. Now I realize you're gonna have to write kind of small because this is how it should be written. In this line, it should be this where you write like a minus with it. So measure of angle QPR plus measure of angle RPS, and then minus the measure of angle RPS to show that I'm subtracting it from that side. And same thing on the other side. So depending if you're a big writer, like I'm a pretty small writer and it's still kind of tough for me. But here I'm just showing. So here's my measure of angle RPS that I had before, but I'm showing that I'm subtracting it from both sides. Okay, and that is the subtraction property of equality. Okay, from here, because I do need it quiet, please. I know I'm leaving you time to write things down, but I just want to make sure that we're on the same page. Now, when I subtract that from both sides, so I used line D, now from line E, when I subtract that from both sides, what am I going to be left with? Kylie? Yes, so measure of angle QPR, so this angle here that's left unhighlighted because the purple and the yellow are canceling out, should equal, on the other side, I still have measure of angle TPS. And then what reason would that be? Subtraction fact, yep. So I subtracted something from both sides. It's a fact that by subtracting something from itself, it's 0. Okay, now, so I use line E. Now, the last line should be what I'm trying to prove. Angle QPR is congruent to angle TPS. So look at from line F, where I'm saying the measures are equal, to now line G, I'm saying the angles are congruent. What reason is that? Definition of congruent angles. Okay, so I had those steps to go through to prove why these two angles were congruent to each other. Now, I definitely, in this proof, left a lot more things that you had to write in because we're going through it together. But it's making sure that even if you saw some of these statements typed out, you have to still understand by looking at what you're given or looking at the picture why they're saying that. That's the whole point of a proof, is why can I say this is true? Okay. Let's look at proof number 2. So proof number 1, I think, was one of the longer proofs on here. We have 3 left. We may not go through all 3, but I want to for sure go through 2 and one of them on the back. Okay, proof number 2 doesn't have a picture, so I am going to show you how I would sketch this. So I'm given that 2 different angles are right angles, and then I'm given 2 angles are congruent, but I have no picture to look at. So if I were to try to draw this, so I know angle DAB and angle ABC are both right angles. So if I were to draw DAB, so say this is D, this is A, and then I know from A to B, I'm creating a right angle. So I'll go like this. So DAB is a right angle. And then angle ABC is also right. And I already have the A and the B. And the B has to be the vertex. So I'm going to draw it this way, A, B, and then go over this way for C. So it's kind of like I'm making a rectangle or a square here. That's a right angle. Okay, and then I have ABC is congruent to, now this is a different angle, BCD. Okay, so I am not told BCD is a right angle, but I am told that ABC, so this angle, is congruent to this one. And I am trying to prove that the measure of DAB is the same as the measure of BCD. So I'm trying to prove these 2 angles have the same measure, is what I'm trying to prove. Okay, so by the picture, hopefully that it should make sense. If these are congruent, this angle should also be a right angle, and then if they're both right angles, they should have the same measure. So hopefully that should make sense. Here's how we prove that. So line 1 just states what we are given. So our reason is that's what we are given. Now we have to go off of at least part of what we're given. So line 2 says DAB, that angle is congruent to angle ABC. So up above, we said that those 2 angles are right angles. And now in line 2, we're saying they are congruent. What property in our packet or on our list tells us that? It's not the definition of congruent angles. That's the right angle theorem. The right angle theorem, part of that says all right angles are congruent to each other. So that's the right angle theorem. So you could make a note to yourself on your sheet, all right angles are congruent. That's part of the right angle theorem. Okay, so I used that part of my given. I didn't use all of line 1. Now line 3 says angle DAB is congruent to angle BCD. So it's saying these 2 angles are congruent. It is transitive. So if I'm given this information here. So notice line 2 says DAB is congruent to ABC. And then I have ABC is congruent to BCD. So if I put line 2 together with this and kind of follow that along, that's what's giving me DAB and BCD being congruent. They're both congruent to ABC. So that is transitive. Okay, so now I've used both parts of what I was given. I used line 2. So line 4 should be what I'm trying to prove. The measure of angle DAB is equal to the measure of angle BCD. So from line 3 to line 4, what reason would tell me that's true? That's the definition of congruent angles. Angles are congruent, measures are equal. Okay, we're going to do one more. We're going to do proof number 3. Proofs 3 and 4 are very similar, but there's parts of both of them that we've used we use properties that we haven't used yet in these two, but they're properties that come up quite a bit. So let's look at proof number 3 together here. In this picture, we are given angle 1 is congruent to angle 5. So I'm going to mark that. Angle 1 and angle 5, they are congruent. That's all I'm given. I am trying to prove that angle 2 is supplementary to angle 5. And what does supplementary mean? Adds to 180. So I know 1 and 5 are congruent. I'm trying to prove 2 and 5 add to 180. Okay? So I start with, this is all I'm given, so reason 1 is given. So that's the only thing I have to go off of. So from line 1 to line 2, angle 1 is congruent to angle 5, so the measure of angle 1 is equal to the measure of angle 5. Definition of congruent angles. Notice how often that comes up. That came up a lot with segments as well, saying something is congruent to a measure is equal. So I used line 1. Now line 3, measure of angle 2 is equal to itself. What property says that something is equal to itself? That's the reflexive property. Okay, I didn't have to use line 2 to get that, so line 2 is still open. Now line 4 says measure of angle 1 plus the measure of angle 2 equals the measure of angle 5 plus the measure of angle 2. Yes, that is, it is basically combining these two lines a little bit. But all that's happening is you're taking the equation in number 2 and you're adding the measure of angle 2 to both sides. You're adding the same thing to both sides, which is addition property of equality. And while it might not seem like a necessary statement to you, that's why statement 3 is there, to show that measure of angle 2 is equal to itself. So when I add it to both sides, I'm adding the same quantity to both sides. So we really did use lines 2 and 3 to create line 4. So now line 5 is coming from the picture. It says angle 1 and angle 2 are a linear pair. Okay, looking at the picture, I see that linear pair, remember, is two angles that form a line. This is actually not on your list, but we're going through this together. This is just the definition of a linear pair. So definition of linear pair. Okay, that's not on your sheet. I realize that. You'll notice if that comes up like on your assignment, it's already typed in for you. Okay, but that's just definition of a linear pair, but it's necessary for the lines to come, why we had to say that. Because now from line 5, if angle 1 and 2 are a linear pair, I can say their measures equal or add to 180. What reason is that? That is the supplement theorem. Oops. Okay, so when you know, the key here is if two angles form a linear pair, then they're supplementary or they add to 180. That's the supplement theorem. So that's why saying line 5 was necessary. So I used line 5. Now line 7, I'm saying 180 is equal to the measure of angle 5 plus the measure of angle 2. That is not necessarily true off of my picture. Okay, 5 and 2, I can't just look at the picture and say that's true. So if I look back, I haven't used line 4, and I have line 6 here. The measure of angle 1 plus measure of angle 2, that's right here, is the same as the measure of angle 5 plus the measure of angle 2. So it's like I'm taking this and substituting it in for this to get this statement here. So substitution would be that reason. Okay, so that allowed me to use line 4 with line 6 to make that substitution. So now I just have line 7. If 5 and 2 add to 180, I can say angle 2 is supplementary to angle 5. What's the reason for that? So if two angles add to 180, then they are supplementary. What did you say, Katie? Yes, that's just the definition of supplementary. Does it say angles on there? It does. Definition of supplementary angles.